Okay, so we're going to learn about dictionaries today, which is very exciting because dictionaries are very important and very useful. So here's a deliberately vague question. Write a function that returns the character frequency of a string ignoring the case. For example, the character frequency of hello world would encode that there is one H, three L's, and so on. Now this is deliberately vague for several reasons. I didn't tell you what the data representation is. Right? So this is closer to questions you're going to be getting in the wild and at job interviews. Right? At job interviews, they do not give you very specific input-output requirements. So how should we represent the answer? And I want to make a function that tells me about the character frequency of a string. Right? So if I asked you this question on a midterm assignment or interview, what would be one representation? There's no wrong answer here. Like any representation would work, right? There's not one idea out there. Yeah.
Like a list of lists, and the inner lists have one integer and one character.
Okay, so we could have two lists. The first list gives us a list of characters, and the second list will tell us the frequency and will match up the indexes. One more idea, and then I'll tell you what my ideas were. So this is important, right? Like, you can't call yourself coders unless you can figure out, like, one of the most important things in computer science is figuring out the representation of the answer, right? And this is not always going to be told to you. So is there really not one more idea out there? I know it's Monday, but maybe we can put a good effort into it. Okay, you've disappointed me. Everyone get out. No. So you figured out one of them. It's the two-list approach is the one first. So that's where we just get a unique list of the characters in hello world, right? So there's an H, there's an E, there's three L's, but I only put the L in once. And this would say something like H has a frequency of 1, E has a frequency of 1, L has a frequency of 3, and so on. Another encoding is the one-to-one encoding. How many characters are there in the alphabet? 26. I always forget, honestly. So I can just define a list of 26 elements. And I can say the 0th element will store the number of A's, the first element will store the number of B's and C's, and so on. Right, so there's two different encodings for this problem. Now, what is true about both of these representations? Like, what am I doing, like, in the background here? Oh, I'm not talking about the algorithm. I'm talking about actual data representation. In terms of a data representation, have you guys never heard this term, data representation? Well, could you appreciate how it would be important that, like, if you want to return an answer, you're going to have to figure out how to represent that answer by a computer, right? And you have to figure out representations which aren't going to be huge. Like, which representation here uses the most amount of memory? The second one, right? Because you're going to have to hold all of these like zeros, right? The second one would be an especially bad representation if you only have a few characters that are available or actually written explicitly. Okay, well, I'll tell you. In both cases, the representations were just sort of giving us this mapping, right? They're somehow saying, look, I'm going to tell you how to get from a string to an integer. Right? So in the first and second case, it was basically telling us that H went to 1, E went to 1, K went to 3. Right? So a mapping that takes you from a key, so in the example we're talking about now was a character, to a value that is a number. This is called a hash function. Right? So a regular list would have the identity hash function, right? Because the position of length of K is at the kth element. So what are the hash functions for the two lists? What are the hash functions for the two lists in one-to-one encoding? So I have to somehow so remember, we have a string, and maybe I can type this into the console. We have a string like hello world, and I want to return the character frequency of this. So I had one representation that looked like this. So it was two lists. The first list was what? H, E, L, O, I hate strings, W, R, L, D? Did I? Oh, no, I did L twice. How about this? H, E, L, O. That's a unique set, yeah? Okay. L2 would be what? So how many H's are there? There's one E, 3 L's, 2 O's, 1 W, 1 R, and 1 D. Oops. And 1 D. Okay. So first list and second list. So now I want to come up with a function that says, give me H and I give you 1 back. Give me L and I give you 3. So how can I do that? So I should be using the indexes here, right? The index of H in L1 corresponds to the frequency for H corresponds to the same index in L1 that it does in L2. Right? So if I want to go from L to 3, so my first hash function would look something like this. Boy. All right. Def hash 1. So I'm going to take just one character. I'm going to take L1, which is a list. I'm going to take L2, which is a list, and I want to return an integer. 1, 2, 3, 4. So I want to return. So first I want to find the index of x in L1, and then I want to return the value at that index in the second list. Right? So if I take hash 1, and I say I want L, what? Oh, a bunch more stuff is missing. L1 and L2. That should be 3. If I give it O, that should be 2. If I give it D, that should be 1. Okay? So see what I've done here? I've used 2 lists to basically make a function that takes letters and gives me the frequency. And I've had to go through some like intermediate data representation to do that. Let's do it with the second one now. So the second one has this list, which I'm just going to copy. And I think I screwed up here because this O should be a 2. So just remind me, 1, 2, 3 after 3, I have to add a 2. So here's our second representation, and then there's my 3. 1, 2, 3. Okay, so how can I make the second hash function now? Yep. I corrected it by making a mistake. Thank you. Okay, so here's my second hash function, definition hash 2. I want to take in the same thing, right? My character and the list representation. Maybe I should call this y then. And I want to return an integer. Okay, so how do I go from a string to the frequency now, right? Well, here's the data representation, right? So if I wanted to get, just think of what the process would be. If I wanted to know what the frequency of G was given this representation, what would I have to do? Where's the frequency of A in the second list? Index 0. What number is A in the alphabet, starting from 0? Okay, where's the frequency for B in this list? Index 1. What's the character for B? Like what order? I'll just tell the answer. A is at 0, its frequency is at 0 in the second list. B is at 1, its frequency is at 1 in the second list, right? If G is 0, 1, 2, 3, 4, 5, 6, then its position is at the 6th element of the second list. So the answer is, you just ask what the letter is in the alphabet, and that's where the frequency should be stored at the second list. So where is the position in alphabet? Can anyone tell me? This is a good, what is the position in the alphabet of Y? The unknown string. Perfect midterm question. What 2 operations do we have on characters that could help with this? We did a whole lecture on ordinals and characters. Yeah. What's an ordinal? Are we just tired today? Okay. I'll stop trying to get answers. I feel bad for you guys. You've probably been studying all weekend, right? The position in the alphabet is easy. You just have to shift everything by A, right? So suppose that Y is A. How can we get Y's position in the alphabet? That would be the ordinal of Y minus the ordinal of A, and then I have to go back to the character. Oh, no, that's it. That's the position in the alphabet. The ordinal of y minus the ordinal of a. Everyone see that? If I put in A, it would return 0. If I put in B, it would return 1. So now I just have to return the second list at the position in the alphabet. And then I can use this hash function. So what was the frequency of the L's in this list? 3. What's the frequency of the O's? So this second hash function has the benefit of being able to report letters that have 0 frequency, whereas the first one didn't. Whoops. Right? Because we didn't encode the fact that characters with 0 frequencies exist. Okay, so why am I telling you this? Generally speaking, you want to index into a list using a string, an integer, a float, anything. Right? We can index a list by anything, provided you give me a hash function. Right? You need to tell me where in the list I can find the object you're looking for. Right? So we did an example where I did 2 different types of hash functions. You don't need to know how to write these hash functions. I just wanted to give you a little bit of motivation for dictionaries. So we have these magic lists. A dictionary is just a list which you can index by anything. Right? So Python implements this data structure as the dictionary. And we're just going to assume Python has a magic hash function. A hash function which tells you where anything goes. Studying hash functions is actually difficult. You could do a whole research project in hash functions if you wanted. We're going to lose ordering though, right? Because the keys, right? So we're going to, maybe I should write this on the board. We're going to have a dictionary, maybe like H. We're going to be able to access elements of this dictionary by keys to get values back. Right, so that's the sort of nomenclature I'll be using. All right, so dictionaries can't be ordered because the keys can be of mixed value. I can have a key 1, I can have a key my name, I can have a key a location in memory, and those are unorderable because they're incomparable. Okay, so for example, an additional way to encode the character frequency using a dictionary looks like this. Right, so I can go into terminal here, and I can create something called a dictionary. And since they're unordered, I'm going to use these curly braces. Are you familiar with these curly braces for... I can't go up? That's annoying. Okay. So I'm going to create a dictionary, and I'm using these curly braces because dictionaries are unordered. Are you familiar with these curly braces when you're using sets? So you know that a set is unordered, right? Like 1, 2, 3, the set 1, 2, 3 is equivalent to the set 2, 1, 3 is equivalent to 3, 2, 1. Right, so we use these curly braces in Python to denote dictionaries to emphasize the fact that they're unordered. But I can say something like this. H had a character frequency of 1. E had a character frequency of 1. L had a character frequency of 3. O had a character frequency of 2. I'm just going to do one more. W had a character frequency of 1, and who cares about the rest? Okay, so here is a data type, a new data type for you called a dictionary. And the way that we use dictionaries is like this. So again, on the left-hand side of that colon is a key, and on the right-hand side is a value. Right, so I can say, what is H at L? 3. What is H at W? 1. And I can index more, I can create new indexes whenever I want. I can say H of 10 is equal to 100. Right? And now that's also indexed, right? So you see even the keys can be of mixed type, right? I can index another dictionary. 0 goes to 0. So there's a dictionary, and here's H indexed at another dictionary. Oh wait, I lied. You can't index dictionaries, unhashable. All right, it's good to know. So ignore that last part. So anyways, I have this dictionary H, and we can, again, just assign new spaces like this. Okay, so now let's write a function which calculates the character frequency of a string and use a dictionary as a return type. So it is Monday, unfortunately. So I'm going to do this. I'm going to code Monday. If I hit the correct keys, let me out of here. Oops. Okay, so let's define a function called character frequency. I want to take in a string, and I want to return a dictionary. Oh, I want to take in a string, and I want to return a dictionary. And I want this dictionary to contain, what do I want it to contain? A string and an integer. Okay, so I use this. So I'm going to have to call in several things from typing now. From typing, import, we're going to need lists, we're going to need dictionaries. Is there anything else that we use? I think that's it for now. So return a dictionary, return a dictionary encoding the character frequency of C's. So I can do something like character frequency of hello would be the dictionary. H goes to 1, E goes to 1, L goes to 2, and O goes to 2. And just one more, character frequency of the empty string should return the empty string. I think I screwed up on some of my other slides. Oh, no, I didn't. Never mind. So don't forget about empty characters, right? Those are also characters, right? So a lot of bugs are created by forgetting that a space is actually a character. Okay, so what do I want to do? Well, I want to return a dictionary. So there are two ways that you can instantiate a dictionary or create an empty dictionary. This is one way. This is another way. Right? That's basically the same difference between doing this to create a new list or this. Right? So I'm just going to do this to make it very obvious that it's a dictionary. Now, I use capital H for my dictionaries because I was taught dictionaries as hash tables. So I just write H for hash table. You can use whatever you'd like, but when I say H, I usually reserve a capital H for a hash table / dictionary. Okay, how can we answer this question now? Right, well, okay. I don't think I can answer this question at the moment. Okay, so let's come back to this, because I haven't shown you the commands are going to need to do this. It just occurred to me. That's probably why this is an example and not a question. Anyways, we'll return to this question about refactoring the frequency code to use dictionaries after I show you a few more commands. So let's go through all the dictionary built-ins. A dictionary in Python is a data structure that stores tuple key pairings, right? So if I looked into, I went away, P3. Can I get my dictionary back? I'm just going to do this dictionary, 0 to A, 1 to B. Okay, if I print out H here, oops, print H. Okay, never mind. So what a dictionary does internally is store tuples, right? Pairs of things. And the pairs are going to be the key value pairs. So again, another representation for our hello world character frequency example would have been something like this. We could have made pairs, right, like this. We could have associated pairs H with 1, E with 1, L with 3, right, O with 2. And that was another data representation you guys missed. Okay? This is basically very close to how Python is representing a dictionary. So what's wrong with, well, what's one downside of using a representation like this? Well, how do I find if I wanted to find the tuple corresponding to L, how would I do that? Okay, if I gave you this on the midterm, a list of tuples, and I said, these tuples are encoding character frequency pairs, find me the frequency of L, how would you write code to do that? Yeah. Yeah, that's exactly correct. You'd have to loop. You'd potentially have to you'd have to walk the entire list to find something. which is bad. You don't want linear time access to a list. So Python stores a dictionary like this, but it also has a magic way of finding L using a hash function. Right? It can do it basically in constant time, right? Using a very sophisticated hash function. But that's the difference, right? Dictionaries are giving us constant time access to things that we would require linear time access to. Okay, so here are the built-ins, or at least the ones that are important. So these are all going to be built-in commands for dictionaries. So remember, you just take your dictionary and you say dot, and then you call the function, and don't forget to use these curly braces, right? So I'm just going to define, suppose I wanted to create a dictionary which paired keys of colors to values of things that have that color, right? So things that are red, apple, fire trucks, cars. Things that are yellow, banana, and cars. Things that are blue, sky, and cars. I just wanted to emphasize that like things can be in multiple categories, right? I could ask a question like this: is there any item which could be any color? Right? That would be a good question to ask on this data type. But in any case, so dictionaries have three things: values, keys, and items. So the items are this. The items are these tuples that I've been talking about. So if you ask for the items of a dictionary, what you're going to get back is this representation. Okay? But you see how it's returning something that's sort of bracketed in this dictionary item thing? Right? See this? Right? So if I take y's and I set this equal to the items of x's, what? What is x's? Is a list. Where did my, oh, h was my dictionary. So here's h.items. What is the type of this? Dictionary items. Right? What is the length of this? 2. Dictionary items isn't a list. Right? I don't think we can concatenate to this. Expected in. Yeah. So this h.items isn't a list. It's an iterable, right? It's some other type of thing that's not a list. So you don't get direct access to dictionary items. You can only step through them in a for loop, right? So I can't say h items of 1, right? But you don't get indexing. Now I can take h.items and I can convert it to a list, and then I can ask for the position at 1. Maybe I can't do that on the same line. Oh, nope, I need to do this. Right? So if you want to index into this items list, you need to convert it to a list first. Right? Otherwise, these dictionary items, everything that we ask from dictionary is going to return as this special dictionary iterable. Right? Because you can imagine you have an enormous dictionary, and then you want to iterate through the items through it. You don't want to make an enormous list in memory of everything that's in your dictionary. The best way to do this is do it in a lazy fashion, to step one by one, right? Just to take one thing at a time. Okay, so the first built-in here is items. It returns not a list, but an iterable that contains key value tuples. There's another built-in called keys. So which one are the keys here? The colors or the items? So that's the key value relationship. So in that dictionary H, what are the keys? Yeah, red, yellow, blue, and the values are those lists. So if I ask for the keys here, it's not going to return a list. It's going to return an iterable that contains red, yellow, blue. Right? Not a list. But you can still do a for loop through it. Right? But you can always convert it to a list if you want. What happens if I ask for H of blue? Not a trick question. What is the value at H of blue? Yeah, sky and cars. Okay, so as long as you're asking the dictionary to give you a value that corresponds to a key, you're going to get something back. What happens if I ask for H of green? Yeah, you're going to get a key error. Okay, it is possible to set up default values for this, which is better, but I'm not allowed to show you a default dictionary. So we're going to have to code our way around this problem. More on keys. So if I ask for the keys of this, is this just the same slide again? There's one more thing here. Okay. So if I say H of green, if I ask for the value for H of green, it's going to give me a key error. But you can always assign something, right? So I can say H of green is leaves, and that's fine. It's not going to throw an index. It's not going to throw a key error because it's not trying to retrieve something that isn't there. It's putting something there that isn't there. So I guess I didn't do values. Did I do values? Okay. I will go into here. I will painfully define this list. So I said cars and what? Apples are red. What else do we got? We had blue. I actually had quite a difficult time figuring out things that were blue. So I said sky and what else? Cars. Can you give me one more example of something that's blue that's not like the ocean? Because the ocean's technically not blue, right? It's transparent. Leaves. But like one word. Blueberries. Don't ever not take the obvious answer. What was my last one? Yellow? Things that are yellow. Biff. Does anyone get that reference? No? Rewatch Back to the Future. Okay, so again, so here's my dictionary H. I can ask for the items of H, which are an iterable of tuples. I can ask for the items, I can ask for the keys, which are going to be the colors in this case. I can also ask for the values, which are all the values, the things that the keys map to. I can sort of duplicate this by saying, I can get the value somehow by saying H at key for key in H.keys, and that should create a list of the same thing that's above it, right? Using this list comprehension. Clear and copy. So dictionaries have the same problem that lists have, in that when you set F to H here, you're not actually going to get a duplicate of the list. You're just going to get two pointers to the dictionary. So you have to copy the same way that you copy a list if you indeed want two copies of something. So here's H. I'm going to copy the dictionary H into F. I'm then going to clear H, which means now if I ask for H of blue, that it tells me it doesn't exist, right? H has really now been made the empty dictionary. But notice F of blue still exists, right? Because I indeed have a copy of it. More on copy. If I have this dictionary H, and I copy that dictionary into F, and then I take H and I append Windex to things that are blue, right? So H of blue is now this. Oh, that should be F of blue. What is F of blue going to be? It's also going to have Windex in it, right? Remember this thing about shallow copies? That we have like a copy of the outer list, but the inner lists are still pointers? Same applies to dictionaries here. So be aware of the shallow copy nuance. Yeah. No, if I appended something to F and then printed it. So the opposite would have produced the same results here. Right, the point is the lists on the inside of the dictionary are all have pointers to them, right, and aren't themselves copied. Yeah. Get. Okay, so there's another way to retrieve values from a hash function or a dictionary, which is safer. So if I ask to get the value for red from H, it will indeed return apple, fire trucks, and cars. If I ask, what do I get now if I ask for H of green? I'm just going to enjoy my coffee until I get the answer to this question. Huh? Nope. Key error. Yeah. Okay, so this is what the get function is for. If instead of indexing to h for green, I ask h to get the value for green, it's going to return none. This is safer, right? Because this is an error. Remember, throwing errors is endgame. Your program stops, right, and it shuts down. So use get rather than using these indexes, right? Because you're never going to throw an error with get, right? You can say something like, get this value, and if it's not there, then put it in. Set default. So I can actually set a default value for green to be the empty list. And now if I ask for h of green, instead of throwing an error, it's going to throw you an empty. But this is not that useful, right? Because you have to know all the items that are going into your dictionary ahead of time and then set defaults for them, right? So you might as well have initialized your dictionary to include all of the initial items and their initial values. So I don't know. This one's not overly useful. The library default dictionary is fairly useful. You can look that up on your own, but I can't show it to you. We also have these pop and pop items for dictionaries. So I'm going to pop an item from this. Remember, the items are the pairs, the key value pairs. So what do I get if I pop an item from this? Well, what did I say about dictionaries and how they're... Well, if I want to pop the last member of this dictionary, which one's the last member of this dictionary? Well, dictionaries aren't sorted. This question, you can't answer this question. The best that you can tell me about this question is going to pop one of them, right? So here's my point. It's going to pop out one of the items, but it's going to give you a quote-unquote random one, right? Because there is no ordering, right? What should come first, red, yellow, or blue? Right? You could say, okay, order them by the dictionary, but now you've imposed an ordering on the keys, right? So you can pop an item, H is going to lose that item, but know that these items aren't going to be popped in any particular order, right? I'm not even sure it's going to be deterministic. Right? You should give that a try in the labs, right? Pop from a dictionary to see if it comes out in the same order every time, or if it could come out in a different order, right? So this is a way that you could just process every item in a dictionary until it's empty. Okay, so here now we're at our questions again. We have 10 minutes. I think we can get through a few of them. Let's now return to our string problem about returning the character frequency. Okay, so I want to do something like this. So I want to make H, I want to create H, I want to make that a new dictionary. And let's do this. Let's initialize our dictionary to something. So let's say for a character in our characters, just set h of c to 0. Okay? I'm going to initialize my dictionary, right? To make h 0, e 0. And then let's just print this h to see what we got in the end. And I'm just going to return 0 for the time being. Okay, so let's go to the desktop. Let's read this in. Where did I store this? Oh, it's in my home directory. Okay. Let's call character frequency of hello world. So all I've done was taken this, and it should have created a dictionary with one key for each letter of this string. So what do I got? I got H goes to 0, E goes to 0, L, O, space, W, R, D. Right? So I have all of the words in there uniquely. Okay, so now I walk through the list again. For C in C's, I just say H of C plus equal 1. That should work. Okay? I'm just going to store that as a dictionary. There we go. So I could say for X in the, for key in the H.keys, let's just print the key and H of key. Right, so it said H is 1, E is 1, L is 3, O is 2, empty is 1, W is 1, R is 1, D is 1. Right? So very easy that like now I can do this question. This would have taken some kajiggering in the other instances. For one, we would have all had to agree on a data representation before beginning. All right, now we can also just all agree to use the dictionary as our data representation. So you're going to get a lot of leverage out of dictionaries, right? I could probably make a case that the dictionary is the most important computer data structure that we have, right? It's especially in job interviews, you're going to use this basically repeatedly. So is there any question regarding this question before we continue? No. Okay, let me show you some other tricks before we do the next question. You can actually just outright iterate through a dictionary. Whoops. For x in h. For x in h, let's print x. And that's just going to give you all of the keys, right? So that was equivalent to this. Oh. Okay? So you can do either. Right? Sort of maybe the second one is more explicitly what's happening, but lots of Python programmers just use the first. Right? You can say for a key in h, right? Print h of key, something like that. Right? So okay, let's do another question now. Write a function that, when given a string, returns a dictionary whose indexes are characters and entries. Sorry, I shouldn't have said indexes here. I should say keys. Write a function that, when given a string, returns a dictionary whose keys are characters and values are the positions of these characters in the string. Right? So given A, capital A, smaller case B, capital B, I want to say that there's an A at index 0 and 1, a B at index 4 and 5, and so on. So let's see if we can do this. Oops. Definition, character index. I want to take in characters, and I want to return a dictionary which associates strings with lists of integers. What slide is this? Look at slide 19. Okay, we need our, we need our this guy. Whoops, what am I doing? That should return this. Okay, off to the races. So maybe the first thing that we should do here is initialize our h. So let's initialize h. Initialize h. Okay, so for C and C's, I just want to create a default dictionary so that I can get a key created for every character in that string. So for C and C's, I want to do something like, so h is a new dictionary. I want to say h of C is equal to, and what should my default value here be? It's not 0. It's empty list. Yeah, it's the 0 of the data type. And in this case, the data type is a list. Okay, so that should give me a dictionary, which for our docstring example, it would have an A in it, a capital A, a B, and a capital B. Okay, so let's just print that just so we can look at it as we're coding it. So let me just do character, what was it called? Frequency, AA, BB, BB. Okay, so that's the dictionary that we've, what? How did that, oh, character index. Right, so we've created a dictionary that just defaulted to these values. Okay, so now I actually have to fill them. Okay, so for C and C's, I want to take h of C, and I want to append, and well, what do I want to append? The index of C in the original C's. Okay, but what's the problem here? I'm only ever going to get the first index out of this. Now let's run it and see what we get. Whoops. What have I done? Whoops, that shouldn't be like that. Yeah, so we got the frequencies right, but all of the subsequent indexes are wrong, right? We just because this index is always just going to find you the first index every time. So we have to be smarter about this. So what I want to kind of do is index from the back instead, and then pop it, right? But then I'm going to have to do a bunch of inversions. Anyone have any ideas? I know I can do this. I just don't want to overcomplicate it. How much time do I got? 5 minutes. So the next 5 minutes, how can we solve this problem? Yes. That's true, but we need to remember the last one. Right? We need to remember the furthest right element. You know, this is probably a good lab question. Maybe I'll leave this for you guys as a lab question. Or maybe I'll... Any other ideas? Yeah. Okay, let's do it that way. Yeah. Okay, so instead of using the index command, I'm just going to do a for loop. So for C's and C's, let's just use a for loop that actually iterates an index, right, through the length of C's. And if C's at K is equal to C, then I want to take H of C and append K. Okay, so I'm going to take a character, and now I'm going to walk the whole string and see where I can match. And when I do match, I'll append. So maybe this will work. Oh, K in range length of C's. Zero, 1, 0, 1. So what have I done? Why am I getting duplicates now? 0, 1, 0, 1. Oh, because I'm doing the characters multiple times now. Okay, I can still do this, right? I'm going to turn this into a set so that it gets rid of all of the duplicates, right? Oh. All right. Okay, now it works. Yeah. This is a horrible piece of code that I wrote. It does not deserve applause. I want you to take that back. Reserve your applause for when I do things that are impressive. Okay, so try to come up with a better way of doing this, because this loop is kind of inefficient. So we didn't get through all the questions today, so obviously we'll do them next time, but please study. 3 questions tonight on paper you guys need to do for me. And I want you to do well.